So, number 3. This one is perfectly timed for today. Uh, and what I really need you to know, it's super important that fractions are negative exponents. Okay. This is a big note to yourself. Fractions are negative exponents. Okay, so this is 1 over 2 to the 1 power. We don't write the little baby 1, but he lives there. He lives on everything. Oh, on everything. Uh, but we don't normally write him. But this is equal to 2 to the negative 1. So I want you to think about the action of bringing that upstairs. Bringing that upstairs on the other side of the fraction bar changes the sign of the exponent. Yeah. Yes. So when you see these same base exponential problems with a fraction, that means that your same base is going to be the number, and then the exponent will be negative. So this is 2 to the 3n equals 2 to the negative 1. Okay, and then the 2's cancel out. Yep. And n equals negative 1/3. Again, just leave these as fraction answers. Negative 1/3 is so much more satisfying than negative 0.3 repeating. Okay, so there's your lesson. Fractions are negative exponents. We're going to use that later on in number 24 in our classwork today. Okay, so then when you're done with that, move it on down to number 7. And tell me, what shape is that? What shape is number 7? Circle. Okay. Okay. This is a circle. And it has a center of, nope, -3, +3. Both are in parentheses, so both need to switch sign. And what is the radius? Square root of 14, which is not nice, but I could tell you it's 3 point something. .7. And I'm just going to say it is 3.74. I'm just going to say 3.7 because it's really hard to graph anything other than the tenths. So 1, 2, 3.7. 1, 2, 3.7. 1, 2, 3.7. 1, 2, 3.7. It's kind of a potato. It's okay. Yeah, it's true. Baseball diamond. Okay, now on these guys, this is a vertical and horizontal stretch kind of at the same time. It's a dilation about the center of the radius, but we are the center of the circle, but we're not going to write that. We're just going to do shift left 3, shift up 3. Don't worry about the dilation part. I'm not going to ask you to do that on a circle. But you should know the left 3, up 3 business. Yes, honey. That would be shifting right 3 if you put shift left -3. Does that make sense? Because it would switch the direction. Okay. Uh I think that's it for the packet, other than we're gonna look at the quiz review in a little bit, so just scooch it off to the side. And then set up this guy. For being responsible and taking attendance. They get very upset if you don't do it right away, getting emails and calls and things. Yeah. The problem with me is I just get so into the super fun inverse lesson. Um, so, so in case you're wondering, I'm going to use 3 colors in this lesson and a straight edge. My usual 3 colors for inverses. These 3. If you want to make your notes colorful. Okay, so I'm hoping that at least one person in the room recognized this as weird situation number 2 that we were talking about on Friday. So weird situation number 1 was don't multiply by a decimal, divide by a fraction instead, make it a whole number. Weird situation number 2 was when you get a squared and then you square root, you have to plus or minus, and that's what this is. And then weird situation number 3 was we can't do it. Okay, and I'm gonna show you in number 24 one that it looks like you can't do, but you can. Number 24 is actually a pre-calc problem. We're just gonna do one of them. I'm not going to ask you to do this one on a test or quiz. I just need to know. I need to challenge my students that get easily bored. So we're gonna do that for number 24. Might be spicy, but no worries. You'll like it. It's not too bad. You'll be proud of yourself. Okay. Now, starting with this guy. What kind of a shape is this? Parabola. And what is its vertex? 3, 0. Excellent. Okay, and then let's do some mental math. It's your favorite. What's 4 minus 3 is 1. 1 squared is 1. 5 minus 3 is 2. 2 squared is 4. Oh, this one's not too bad. Okay. Any questions so far? We're good? Okay, now we're going to do the steps for this one. So, and remember, I've gotten too lazy to write out all the words. So what would I do first if I plugged a number? Yep. So parentheses first, -3. And then what? Square. Okay. And that's all I'm going to write for the moment with my blue pen. Now I'm going to switch to my pink pen for the inverse. Okay, what do I do to the table? It's the best part. Okay, what is the equation of the line of reflection between these two? I'm going to write it every time. Y = X. Perfect. Do you think that might be something I would ask you on a test or quiz? Did you hear any foreboding, foreshadowing music just then in your mind? Really, just do that every single time. Just get it in your routine. This one looks like Roz from Monsters Inc. to me. Like just the top of her head and her glasses. Mike Wazowski. Okay. Now, this is a sleeping parabola. So we need to find the equation of our sleeping parabola. So the first step would be to undo the square, which is square root, however, plus or minus. And then add 3. Plot everything. Yep. Okay. So I'm just trying to decide where I want to write it. So G inverse of X. Okay. So notice all of this stuff is going to go in front of the X that I start with. And then plus 3 on everything. Okay. Now let's pretend that Miss Talbot was a nice lady, which she's not. And she let you use your graphing calculator on your quiz, but she's not. So let's just pretend though. I did the wrong thing. So there's a way you could check your answers if you wanted to. You can do this on your chapter test, but you could graph the original parabola and then you could take this and split it into 2 equations and graph them both separately. That should give you the sleeping parabola. So that works just in case you want to check your answers. And then just for grins, I like to throw in a couple of extra things. Just so nerdy. Also, you guys know that did you ever think about the fact that your calculator screen is wider than it is tall? So your graphs are distorted unless you go to Zoom 5, which makes it actually in the proper proportions. And now you've got the line Y = X. You've got your original parabola and your sleeping parabola. So if you do Zoom 5, it'll make the little scale the same on both, so it actually comes out proportional. Wow, Mr. Sabat, You need to get a hobby. Yeah, I know. Okay. Last thing for this set of problems. Do you guys remember the last thing we did on Friday? We're not done with this one yet. I have to remind you about the trick with domain and range. Okay. So going back to quadratics. So this is a parabola. The domain is all real numbers. And this is a positive a. So here's my original equation. The range is y is greater than or equal to k. Yep. Yep. You're already there. You're already there. You're doing it without me. I love it. Okay, so this guy comes up here and becomes x is greater than or equal to 0. And this guy comes down here and becomes all real numbers. This flips just like the table, just like the steps. Domain and range flip too. Okay, so that's where we're at right now. How you feeling about inverses?
Better.
Good. Okay, now we're going to do the pre-calc one. And if this one is spicy, it's okay. I know I want you to be proud of how much that you're able to do. Seriously. You'll be able to do a lot of it. I promise. Okay, so while you're setting this up, I have some questions for you. And we've answered a couple of these before. What shape is the inverse of a line? A line. What shape is the inverse of a parabola? A sleeping parabola. What shape is the inverse of a cubic? What shape is the inverse of a cube root? The cubic. What shape, this is weird. What shape is the inverse of a square root function? Half a squared.
What?
Right, okay, because their square root function's just the half. So the inverse can only be the half. It doesn't make a parabola. It makes a half and a half. Which is weird. Okay, what is the inverse of a rational function? Don't know. Okay, let's see. So we're gonna spend quite some time here, so buckle in. We're gonna go nice and slow. This is a pre-calc problem. Again, totally okay. We've got this. First, I want you to recognize that it's a rational function. Okay, it's a rational function because the x is in the bottom. All right, now we don't really graph these with a table. We just sort of make asymptotes and wing it, right? Okay, so for the original, where is my vertical asymptote? Okay, so let me bring this back over for you. So here's my, it kind of looks like this guy here. Vertical asymptote is at x equals h. So it would be any number that was after x in the denominator. There's nothing there. 0. Okay, super hard to draw. I'm just gonna put x equals 0 here. Just pretend that there's a dashed line there on the y-axis. Okay. Next question. My horizontal asymptote is at y equals k. Notice in this one, they were jerks and put k up here. Oh, no. Yep. Okay, last question for the sketch. Is it a positive or negative A value? Positive, positive 2, correct? Okay, which means that my hyperbola is located in the top right and bottom left. So just sketch him in. Okay. Now, you guys know enough about inverses probably to wing this problem. What do you suspect, just from the knowledge of what inverses do, is going to happen to the vertical asymptote on the original?
What?
It's going to become the horizontal asymptote on the inverse.
Oh,
And then the horizontal asymptote on the original is going to become the vertical asymptote on the inverse. They'll flip. And then these two will also flip, the domain and range. Okay, you know all that stuff. That's cool. Great. What I need to teach you now is, how do I get the inverse equation, the function? How do I do it? And I'm going to do it in two ways. I'm going to do it with the steps like we do it in Math 3, and I'm going to do it how they do it in pre-calc. And we're going to do it down here. So we're going to do Math 3 style, and we're going to do pre-calc style. Okay. In Math 3, I would list the original steps and list the inverse steps and write the inverse. Okay, however, how do I write what happens to it when it looks like this? Yes. Okay, what you need to do is you need to convert this to this. Thinking about exactly what we did in our warm-up. So remember, fractions are negative exponents. Okay, so now, what's the first thing I did to it? Okay, so the first thing I did to it was a -1 exponent. Then times 2, then plus 1. Alrighty. -1 divide by 2. Okay, and here's the question. How do you undo a -1 exponent? That's not really a thing. Okay, do you know that a -1 exponent is just a flip? Yeah, so just flip it back. A -1 exponent is the inverse of itself. because it's just a flip. So you're just flipping it back. Flip again, flip, flip, flip. Okay, you see why this is spicy. But if somebody shows it to you, you can do it. Okay, so what is it? Y inverse is, okay, so start with x minus 1. Divide by 2 on everything. To the power of -1 on everything. And the power of -1 is the flip. Isn't that fun? Okay, now we're going to do it pre-calc style. In pre-calc, Miss Rice will want you to do this for almost all of them. Mr. Knight, though, he's going to want you to do something different. He's going to want you to say, well, if you're flipping the x and y in the table, why don't you flip the x and y in the equation? Again, if you flip the x and y in the table, why don't you flip x and y in the equation? Okay, so now we want to get y inverse by itself, so it looks like this. So the goal is to get it to look like this guy. So -1 from both sides. Do you see where it's going? Okay, now right here you have two options. You can either multiply both sides by y inverse, or you can cross multiply, which is the same thing. I'm going to multiply both sides by y inverse. Okay, and then how do I get it from here to here? Okay, so now let's go back up here and make sure that our horizontal, vertical asymptote, domain, and range makes sense. So taking a look at our equation, they're both the same. What is the vertical asymptote? X equals 1. Just the flip. Yep. So this guy comes up here. What's the horizontal asymptote? Whatever's off the end. 0. Flip. Domain, all reals except x will not be 1. Range is all reals except y can't be 0. Okay. I feel like I'm working in pen and I'm going to screw this up at some point. And it's just super detailed. Now's not the time. You know, okay, so we still have a positive a value. Man, how cool is that? Person that just came in and I shooed out of here. Guess what class they want help with? Pre-calc. Okay. As fascinating and wonderful as that was, that is over. Now please find your quiz review. I have a couple of things to tell you on that. Actually, just one, I think. Okay. So pretty. I think it's pretty. What I want to do. This is what I want to do. Okay. Can you see it? Okay. Your next quiz will be on the block day, Wednesday or Thursday. No notes and no calculators. This time it's going to be the last 15 minutes of class because the class work will actually help with the quiz. Topics you should expect to see include. Okay. Number one, graphing a non-function. There's only two possibilities. Do you know what those two possibilities are? Correct, sleeping parabola. No, parabola is a function. Circle. You only have two options for graphing a non-function. Sleeping parabola and circle. That's it. So you can narrow your focus down to sleeping parabola and circle, which is good. Writing the equation of a non-function from a graph. So that's the same thing. It's just that you're looking at the picture of the graph and then writing the equation from it. The hardest part about, well, circles are easy. The hardest part about that is the sleeping parabola. And you remember that K is in the parentheses and H is outside. That's, you're just gonna have to drill that in your mind. Solving a same-base exponential. That's the ones we've been working on the warm-ups, number 1 through 4, where you like get them the same base and cross out. And then finding an inverse, understanding the relationships in a table on the graph between a function and its inverse. So making a table with mental math. There are problems that's not bad numbers, I promise. You do need to know a couple of cube roots. We'll talk about that in a second. And flipping the table and then graphing it and reflect on the line y equals it. You know all that stuff? Okay. There are some things that you need to know. Hold on. Muy importante. You need to know this. You need to know this. You need to know this. And you need to know this. Yeah. Be able to figure these out in your head. What's the cube root of 8? 2. What's the cube root of 27? 3. Cube root of 64? 4. Cube root of 125. It won't get any higher than that. Those are the only ones. Okay, however, what if I say cube root of -8?
A -2.
-2. Cube root of -27. -3. Cube root of -64.
-4.
Cube root of -125. Okay, we got it? Okay, that's all. I mean, you should know the cube root of 1 is 1, and you should know the cube root of 0 is 0. But this is as high as this would go. Okay. So over to here. So this is kind of what I'm talking about on this. Like, you should know this is 4 cubed. You should know this is 5 squared, 5 cubed. And you should know this is 9 to the negative 2. Do you see the negative 2? Okay, after today. All right. So I think I'm gonna, what else was my plan? I had warm-ups, stamp. Okay, so I'm gonna come stamp and then you guys work on your quiz review, please.